for our project was primarily threefold. The first one was that we wanted the safety community to be more proactive and efficient because the pace at which these models are developing is so rapid that it's important that even safety evaluations keep pace with that. The second one was we've seen a proliferation of AI safety institutes across the world. So we wanted these safety institutes to take a more proactive approach at forecasting what future risks were going to look like. And the third one was to have a shared common language for different stakeholders. When we're talking about the safety community, the security community, government, industry, as well as researchers. So with that in the mind, we set out to do evidence review of the current evaluation landscape. And what this really looked like was that 85% of evidence today focuses only on technical capability evaluations of different AI models. And this is not surprising because it's one of the most cost-effective means to do so. But as we all know that AI is a sociotechnical system, and therefore it's increasingly important to not just look at the technical elements of the system, but also how it interacts with the human being at the end of it, and how these interactions and capabilities then have an impact on society at large. But what we found was, based on an evidence review conducted by Weidenger et al., that only 9% of the evidence currently focuses on a systemic level impact assessment, and only 5% around focuses on human interactions with the AI system. This clearly needs to change. Currently, there are three popular approaches to evaluation. The first one is benchmarking, which again focuses on the capability layer of the AI models, where you give a model a predefined task. For example, you could ask it, what is the compliance with recognizing a particular symbology belonging to an extremist organization? And based on how different models actually perform that task, you can rate them on their level of compliance. Red teaming, on the other hand, is a more concerted effort at finding at what point the model is going to break and give you information that it shouldn't. For example, you could ask the model to give you instructions for creating a weapon, and it wouldn't do so. But if you frame the same prompt as something for your child's school project, it might actually do so. So it's actually trying to figure out at what point the model breaks down and gives you this malicious information. And the third aspect is human participant studies, which are more cost-effective, which are more cost-intensive to design. The question really is, how do you design a survey or an experiment to understand when you ask an AI model to create some propaganda at scale, how is it really impacting people at the end of it in terms of their beliefs, in terms of their persuasive levels, etc. The challenge remains in terms of the evaluation landscape is three things. The first one is external validity. So like I said, a lot of the evaluations today focus on the capability layers, and you have benchmarks and red teaming studies being undertaken. But it's very difficult to externalize and generalize the findings from these methodologies to other contexts because, as I said initially, AI is a sociotechnical system, and as you move beyond just the capability layer, you have the human interaction and the systemic layer, which just adds on more context to it. So ensuring that these methods are externally valid is the first problem. Linked to that is the fact that because these are so difficult to make generalizable, we don't really know to what extent in any given risk area we're actually being able to cover the risk that's been defined. And then linked to that is the fact that it's very difficult to scale these evaluations at the pace at which AI models are expanding. And because of these three interlinked challenges, and I would argue because of it, it becomes very important to go out from the concentric circle layer and add in more context and then design evaluations. And therefore, our attempt with this briefing paper was to really look at the malicious actors' point of view, really see how they are adopting AI in the different threat landscapes, and then design these evaluations. So with that, I'm going to now hand it over to Adi to talk about the three different threat areas.
Great. So yeah, with that kind of contextual framework in place, we were able to really start thinking about, thinking through these risks, these three risks that we focused on, malicious code generation, radicalisation, and weapon instruction and attack planning, as Tvesh outlined, in a bit more of a kind of calibrated way. And there's this kind of three-way breakdown that you see on the screen there. So thinking about the sources of generative AI risk, which is that kind of those three domains which I've just talked about. Also conducting a more of a kind of high-level scan of the existing evidence, and then using that to kind of forecast anticipated applications in those three areas. And these will tie in with the inflection points that Anna, the kind of future inflection points and risks that Anna will talk about afterwards as well. But I just want to pause, I suppose, here on this pyramid. This is actually taken from an earlier piece of research that Anna, myself, and a couple of other colleagues collaborated on, essentially looking at kind of the implications of generative AI for national security. I think this pyramid is quite instructive for a few reasons. It kind of shows how the threat is linked to willingness to do harm. And obviously for malicious actors, that willingness to do harm is pretty high. But even then, will be divided across a few different kind of categories. You'll be divided across your organized adversaries, which are themselves divided across kind of organized hostile states or organized crime groups, and then also your kind of lone actors who might be working from their own bedroom. But you also have these kind of incidental or unintended risks in the bottom right corner there, and these kind of refer to improper use, really, rather than thinking about malicious capabilities per se. So this might refer to how AI tools might be used improperly in the critical national infrastructure context, in various kind of public sector contexts, in the private sector, also in the kind of DIY context as well, how people might be using AI tools from the comfort of their own rooms in inappropriate ways, which aren't necessarily kind of malicious in intention. And these might be come about for a variety of reasons, people's judgments being kind of clouded by the need to kind of get hop onto the generative AI wave, really. We focus in this case, we focus in this project, as Tvesha outlined, on malicious actors, but we have argued in previous research that these kind of improper use cases, improper use, incidental cases of AI use have kind of necessitated a bit of a shift in the way that the national security community specifically thinks about these AI harms. Because back in the days when the most sophisticated weaponry in the world was reserved for a very kind of small percentage of the global population, the national security community in those days was really programmed to anticipate threat from those who had a particularly high willingness to do harm. But I suppose what's changing now is this kind of proliferation of really advanced technology to an almost global audience is kind of changing that equation somewhat. So, although we are primarily focused on the malicious use cases here, I thought it's kind of worth just contextualizing it a little bit and reflecting on the fact that these kind of incidental and unintended use cases in the bottom right corner there are also kind of forming a kind of category within their own right in this space, and it is changing the way that the national security community need to think about harm. So while the national security community has kind of long been programmed for this adversarial or malicious threat, I think it's probably fair to say that the tech/developer community, perhaps not as much. I think historically there's perhaps been maybe a little bit more naivety around how bad actors will weaponize technology that is kind of ostensibly being developed for the good of humanity, or in kind of OpenAI's words, to kind of automate all kind of economically valuable work. You can see here that evaluations for malicious use, this is from 2023, evaluations for malicious use represented by the red bars on the chart, were really outnumbered by quite a few of the other categories there. As I say, this graphic is from 2023, so perhaps presents perhaps a more updated figure would look a little bit different given some of the kind of changing sentiments in this space. For example, in terms of focusing a bit less on misinformation or toxicity as a result of some of the noises coming out of the new US administration, and a kind of push towards focusing on more traditional security threats. But certainly I think at the time that we were writing this paper, this kind of graphic was very instructive in terms of guiding our thinking and wanting to put a bit more of an emphasis on the malicious use cases, because even though in the national security space, this is obviously really well understood, I think we were often finding that in conversations with developers in the tech space, perhaps a little bit less so. So moving on to understanding the existing evidence. So as Tvesha mentioned, as part of this briefing paper, we wanted to really, before going on and forecasting inflection points and risks and the kind of developments in the technology that we need to see before, before certain inflection points came home to roost. We did want to understand the kind of existing landscapes so that we had a kind of solid foundation upon which to build. And you can see there's a few bullet points there for the 3 different threat areas. I'll focus most of my comments on the first one for purposes of time, the first row on malicious code generation. And essentially we found that on the malicious code generation front, that AI tools are still kind of lacking the specific capabilities required to independently create operational malware. Partly because this requires a very delicate balance and trade-off between things like kind of covertness and functionality and things like that. But at the same time, certainly finding in our kind of open source literature review and focus groups and research interviews that cyber criminals certainly are using generative AI to uplift their capabilities and refine existing malware, if not to create wholly new strands of it, and also to just augment social engineering attacks in general. Since this paper was published in, I think it was July or August of last year, we've had to kind of update some of our thinking to account for the pace of change, particularly when we're thinking about the launch of reasoning models, kind of left, right, and center at the moment. And I think there was certainly a kind of consensus view back around when we were writing this, regarding the kind of difficulty of autonomously identifying and exploiting vulnerabilities using AI systems due to limitations in the system's reasoning ability and limitations in their training data as well. Essentially, when we talk about autonomously exploiting vulnerabilities, we're talking about achieving access without needing victim interaction by exploiting flaws in the underlying code. But that picture might be changing, as I've alluded to. AI autonomously finding and exploiting vulnerabilities in various open source software projects I think we've seen in recent months. And some benchmarks had this capability rising from around 21% for GPT-4o to around 79% for O1. So certainly some evidence that in some projects that this is becoming an increasing concern. But still fair to say that systems still do struggle with kind of more complex, more realistic scenarios, if you like. So actual published systems, not yet kind of very limited evidence of them having autonomously executed real-world intrusions into networks. So still kind of monitoring that landscape, but certainly in the academic research, more and more concern in that regard. And another increasingly prominent theme here is kind of collaborative teaming for cyber threats. So thinking here about kind of how state actors are using AI in quite an exploratory way to survey target systems. Generally, the ransomware entry phase can be quite technically challenging, and so there's definitely a role here where generative AI can help speed some of that learning process up. Another thing to bear in mind is that AI models often produce what you might call near misses that humans with fairly moderate cyber experience could quite readily address. So there's a potential synergistic benefit here between offensive efforts that could be taking place. And also worth bearing in mind that these kind of near misses aren't typically reported in the benchmarks. So there's a potential there that some of these benchmarks are understating model capability in this regard. And finally, you've got this idea of collaborative teaming not just taking place between human and machine, but also between different models and between different AI systems. So, potentially a dynamic where models are refining each other's outputs. That could be very useful for multi-step tasks, which are kind of very error intolerant, where only one thing needs to go wrong for the whole kind of stack of cards to fall down. The more that you can get models refining each other's outputs, the less likely that kind of failure in that regard might be. And then I'll just touch on very quickly on the radicalisation and the weapon instruction attack planning sides. One on the radicalisation side of things, we found no real evidence regarding an autonomous delegation of tasks from terrorist and violent extremist groups to AI agents. And we also found kind of different dynamics between your kind of terrorist and violent extremist groups, perhaps compared to your cyber criminal groups. With the former, you perhaps have a bit more of an emphasis on human direction, human oversight, perhaps kind of ownership over the message as well, that these terrorist and violent extremist groups are trying to put out there into the atmosphere. That might be because of its kind of sanctity. It might also be just because of an inherent paranoia amongst some of these groups. And these things are really important to kind of flesh out to get a better sense of really how those factors are affecting patterns of adoption. And there'll be differences even between different types of terrorist and violent extremist groups as well. So different kind of appetite for immediately integrating AI in kind of extreme right-wing terrorist groups, and potentially different patterns of different preferences and patterns of adoption amongst radical Islamist groups in comparison. On the weapon instruction and attack planning side of things, skill and infrastructural barriers, I think those arguments have been really well rehearsed in the last few years in terms of how they impose some really kind of hard physical limitations on what autonomous agents can do in this space. But certainly uplifting novice capabilities and in providing information kind of comparable to existing sources, comparable to or better than what existing kind of search engines can provide, that also came up quite prominently in our research as well, due to these models' ability to really synthesize information from right across the web. So this slide shows some of the kind of anticipated applications. So we developed a list of anticipated applications which may be enabled by the inflection points which Anna will discuss. So I'll just focus again my comments mostly on that kind of malicious code generation side of things. So one of the things that we were looking ahead to here was AI for malware detection evasion, essentially. So future techniques which allow malware to alter its code when it executes or kind of rewrite itself entirely. Developments in those regards will certainly improve detection evasion. And utilizing machine learning techniques to identify different patterns and then having generative AI generate kind of upgraded variants, that could all make that a lot more feasible. Also, lots more discussion around the role of generative AI and the kind of malware that autonomously generates its own payloads based on different systems it encounters. So here you could have malware which is identifying the most lucrative repositories, kind of transaction systems, confidential information, and kind of crafting bespoke payloads in order to extract valuable information outside of that. And that sort of data exfiltration could be done within legitimate business processes as well. Masking command and control channels, evading conventional detection. So lots of concern there as well. Also, a theme just worth touching on, I think, this theme of decentralized AI systems and how they affect willingness to adopt. I think this was a consistent theme across our different threat areas. An increasing focus on autonomous malware and localized AI, I think, in the literature at the moment, and the discussion of transition to on-device, edge computing could have potentially big malware implications. So you could end up with things like malware, acting as an autonomous agent, devising plans, achieving its own goals, advanced persistent threat attacks that are kind of adapting without necessarily relying on outside instruction and feedback, could potentially be quite significant because the current confidence levels that we have in our critical national infrastructure, kind of afforded by air-gapped networks, could, in some scenarios, be perhaps that confidence could be eroded by some of those developments. And just additionally, in this kind of agentic era, this kind of agentic Gen AI era, which we seem to be in at the moment, we're going to have generative AI systems which have access to and are integrating with a much broader range of applications, more AI-enabled devices, more and kind of larger, more complex attack surfaces as well. That kind of privacy security nexus of the agentic AI push at the moment, uncertain whether that's kind of being adequately thought through in some of the big AI labs at the moment. Finally, just before I hand over, lots more speculation as well in the media around this prospect of kind of autonomous end-to-end cyber attacks. I think we found this was probably uncertain in the next kind of few years. But what is almost certain is that you'll have skilled actors who will be automating parts of the attack chain to evade detection. And this kind of human-machine teaming is definitely going to make mitigation a lot more difficult without effective AI for defense. I won't go into the other examples, but more information in the actual published paper as well. I'm just going to hand over to Anna now.
Perfect, thank you. I'm Anna, and I'm going to talk about the inflection points that we came up with. So I'm going to talk about what are inflection points, how we're defining them, talk about different inflection points across the different threat domains. Similarly to Ardi, I'm going to focus on the cyber aspect, and then look at some recent evidence. So inflection points are something that we use to conceptualize our analysis to try to understand and forecast where certain applications or capabilities of generative AI systems would lead to a significant elevation of risks. So what we're concerned about is when something changes and it will lead to a big uplift in the risks. There are different types of inflection points. So there are inflection points that are domain specific. So it could be certain technological advancements, certain contexts of, say, autonomous generative AI agents. And then there are also systemic inflection points that will shape risk across all the different threat domains. So touching on what Fesha spoke about earlier, that was the kind of outer systemic layer of that diagram. So I apologize for a very text-heavy slide. We thought it was nice in some ways to have a lot of the text up there. But I'm just going to talk through a couple of the examples. So as Ardi mentioned, we wrote this paper I think it was published in June of last year, which in AI terms is like many years ago. But in malicious code generation, the kinds of things that we're thinking of is when reasoning is uplifted in a way that generative AI systems can maintain a model of code. It might mean that they can improve their strategic decision making and be able to run more end-to-end tasks than they can now. Also, we thought about high-quality training examples. So if we got to a place where generative AI systems are trained on better examples of sophisticated malware, we could see a place where suddenly their offensive capabilities could far surpass their defensive. And then finally, teams of agents. So if autonomous generative AI agents can cooperate, learn from, and adapt to one another's experiences, that would also uplift capabilities. And another thing to think about when thinking about malicious code generation is the types of different actors and which uplift we'll see where. So you can imagine already, if you're a highly skilled technical actor, you will be experiencing uplift. However, at the novice end, if you don't have technical coding ability or resource, the ability to fine-tune models, that uplift won't be experienced at the same extent. I'm also going to touch on some of the systemic factors that we have up here. So two I wanted to think about was what we've called AI proliferation and decentralized training. So there's been big shifts in the AI space over the last few months that mean, one, we now know it's much easier to transform a model into a reasoning model with only few training examples, so I think less than 1 million samples. And that means we're going to have big proliferation of reasoning models. And also, there has been advancements in decentralized training and decentralized learning. And what that means is the people that have the resource to train AI models is changing, and more people will be able to. So I think both of these things will have systemic implications for the other risk areas. So we also just want to run through some examples of tests and evidence of these different capabilities. So the UK and the US AC tested OpenAI's O1 model. And I'm just presenting here their results for cyber, but they found that O1 solved 45% of publicly available cyber security challenges. And when evaluating software engineering capabilities, they found that they reached a success rate of 50% compared to 67%, which was like other best performing models. And it also found that the reasoning capability of this model was kind of roughly equivalent, as you can see, to other leading models. There was also a paper published by OpenAI, which reported on different cyber operations, and this gets an idea of how malicious actors are already using these capabilities, and this was published in October. And what this showed was that actors were using these capabilities, but more for parts of the wider risk chain as opposed to end-to-end. So it would be things like vulnerability search, maybe scripting help, maybe research into something specific like programmable logic controllers, or to build different toolings that might be around malware or scraping the internet. So I'm now going to kind of conclude and talk about the overall implications of our analysis. So we came up with different implications for each of our threat areas. So for malicious code generation, we think the UK cybersecurity community should monitor and track code generating systems, cyber offensive knowledge, their reasoning abilities, and strategic decision-making capabilities. In terms of radicalisation, we need stronger feedback loops between the security community who detect and combat radicalisation and the eval community who are running the evaluations. They have an understanding of these risks. And finally, for weapon instruction and attack planning, we also need the eval community to focus on capabilities like prediction, adaptability, multimodal processing, and also for them to collaborate and communicate with the security community to make sure what they're testing reflects the evolving operational picture. So our final conclusions are that AI adoption will not solely depend on properties of a given AI system, but also on actors' characteristics and readiness to adopt. So we need to pull our evaluations to not only consider model capability, but also consider the kind of operational context in which they will be deployed. And this means we need to move beyond these like very tech-centric perspectives on malicious AI use and encourage collaboration between national security practitioners and AI safety researchers. Thank you so much. I think we've got 15 minutes now for questions.
Great, thank you. Thank you so much, and well done on managing that problem with the slides. That was really well managed. We've got a number of questions coming in, but please do submit them. And if you want to ask a question in the room, just raise your hand and we'll get a mic to you. I'm going to take one that has come in then that says, what's your suggestion to Gen AI researchers about mitigating these risks?
Shall I?
You can start.
I think evaluations are a strong approach to thinking about model capabilities. So if you're thinking about the cyber context, evaluating the capability of the model to carry out these actions. But I think there's probably other types of evaluations that are less done now, which would be things like post-deployment monitoring of usage data, for example, to build up a better understanding of like how these systems are actually being used and building out mitigations on that side as well as the model capability.
Yes, I think in one of Tavesha's slides, I think her final slide, where it kind of had the different kind of methods and goals of different approaches to AI evaluation. Lots of focus on approaches like red teaming, obviously, and those have gained a lot of currency since the kind of eval space really took off in these last few years. But also more interest in emerging areas like mechanistic interpretability, and kind of building on what Anna was saying in terms of getting under the hood of these systems and getting a better understanding of how they tick in order to then, devise better kind of roadmaps, kind of being able to better map out how they might behave or misbehave, and then put mitigations in place there as well. Simulation is another area which is gaining increasing interest as well. Also, as a way of potentially, as a kind of safety enhancing way of conducting evaluations from a kind of research point of view as well, because a lot of the harms that we're talking about here aren't necessarily harms you want to be exposing researchers to. So if simulation potentially has a role to play there, then that's obviously going to be looked at more and more.
Yeah. Any questions in the room? If not, I'll go down to the Slido. So there's somebody's put in a question saying, how can we balance the trade-off between accessibility and harm? Is open access worth some level of risk?
My reflection on that is it pretty much is, and I think the debates that I remember having a couple of years ago on open source models or open weight models and the harm that they create and how it kind of negatively impacts law enforcement investigations and things like that, I think that ship has kind of almost already sailed when you look at the innovations that are coming out of not just Silicon Valley now, but also China, and I think DeepSeek, the kind of DeepSeek hype accelerated a lot of that, the kind of really impressive products that they were putting out. So I think it's almost, I think the open source ecosystem is just way too mature at this point in time to really be, I think, questioning the value that it brings. I think there is an element of needing a bit of both, or kind of accepting that there is a trade-off there. And also bearing in mind that I've kind of touched on some of the national security community kind of context in this presentation. But when it comes to how they leverage some of these tools, for various kind of obvious reasons, national security communities in this country and other countries are going to be reluctant to be bringing in or sending data back to data centers in California and using kind of commercially available tools from US company. They inherently prefer to be experimenting on, building on stuff that's out there open source already. So it is a bit of a two-way street there in terms of the capabilities that these systems potentially provide malicious actors, but also when it comes to the kind of defensive side of things and how national security practitioners experiment with these tools, they need them as well. So yeah. That's worth bearing in mind. And
Anna, you spoke to the fact of needing the security community and the AI community to be working closely together on these issues. How can we achieve that?
Yeah, so I'm at the AI Security Institute, which sits within government. So a lot of the work that we do is trying to bridge those gaps and try and build the right empirical evidence that answers the questions that the national security community currently has. Because I think, as a computer scientist, we sometimes think we know best and we should build these end-to-end evals, but we often don't have the domain expertise, and it's really valuable to bring those two things together. And I feel like a lot of the national security community have like different levels of maturity in thinking about AI risk, and the AI researchers can bring that more maturity thinking about AI, I think, come together to create much more robust and comprehensive evaluations.
Yeah. Deeper understanding of the whole area. That's great. So a question that has just come in is, are state or non-state actors the biggest risk in the short term?
It's a big question. I think in the short term, I think on the state actor side of things, there does seem to be much more of a sense of experimentation. Things seem to be a lot more exploratory rather than kind of imminent. Whereas I think with some of the more individual non-state actor, or firstly, it's probably worth saying that those lines are often blurred with some of the countries that the national security community in this country might be most worried about. So there is an element of kind of diffusion between the two. But I think if you are going to split it out, then I think the kind of bureaucracy and the kind of the layers of bureaucracy that state actors tend to have to work through in order to actually operationalize these tools, compared to kind of a lone actor just downloading something off of off a Hugging Face and kind of going for it, I think puts the balance slightly in favour of being concerned about your non-state actors, just because of the flexibility that's now offered and the kind of speed to deployment that's now available. But longer term, I would probably worry about the former, the more more organized efforts, also because of how they're inherently linked to geopolitical dynamics and the kind of race to AGI, and how that might also then be linked into kind of real-world armed conflict as well. Yeah. So those are the sorts of things which I'd worry about longer term. But I think it all has to be part of a kind of holistic response, regardless, particularly because, as I say, those lines between state and non-state actors are often so blurred.
Yeah, and just following up on that, another question that's come in that's follows up. It's asking, what's the most urgent of the risks that we've talked about? Which is the most urgent that we should be focusing on at this point in time? Now, that is bound to shift quite quickly, I'm afraid, as new models and new ways of the models working. But today?
I think probably today it would be the malicious code generation. Yeah. I think my view is radicalisation, having these technologies fully ingrained in, say, terrorist groups' operations, feels like it will be less sure near term because of the operational security concerns. So I think it's what you kind of touched on, which is right now, individual actors, less security concerns with technical ability will be able to use these systems most effectively. I don't know how that will change as these systems become more proliferated, people are much more native to using them, and their capabilities are higher.
Yeah, and Tvesh might have a view on this as well, but I think I'll broadly agree on that, and I think in my segment I was trying to really shine a light on the pace of change that we've seen since this paper was published and the implications it's had on our thinking on the cyber threat side of things specifically. So I would agree with that assessment. I think one of the reasons that we focused on radicalisation was because it was a bit more of an underexplored area in the literature, and because there'd been so much talk of the persuasive and kind of manipulative abilities of these models, and we wanted to really use it as a test case to kind of see, to get an understanding of how advanced that really was, and then to forecast, okay, what would it really take? So I think some of what we found in the radicalisation space was definitely concerning, in terms of if some of those hurdles that we identified were able to be kind of surmounted, then I think you'd be looking at a pretty concerning landscape on that front. But in terms of, I think, the more immediate term side of things, I think some of the stuff that we found on the cyber side was of most concern.
Yeah. Okay, we've only got time for one last question. I'm going to take the most upvoted on Slido. It says, can you share some examples of the most successful attacks using Gen AI? And is there any public information on scale and economic harm?
Ooh.
One example that comes to mind is pretty sophisticated deep fake corporate fraud that took place in Hong Kong. I think it was a UK company, a financial institution of some sort, where an employee there was kind of confronted with this kind of multimodal AI-generated image, audio, video, all kind of coming together as one, kind of simulating, kind of essentially convincing this employee that they were talking to members of their board, their CEO, their CFO, and ended up kind of authorizing a kind of $25 million transaction to these fraudsters. That is, I think, what's economic and financial harm, fairly high end. And when you consider that these, in the grand scheme of things, these technologies are still at a relatively immature phase of progress, you can only imagine that getting worse and worse. I don't know if any other examples come to mind.
The most recent one I can think of is the Cybertruck explosion outside Trump Tower. And that feels like a much more kind of novice use of generative AI, but they used ChatGPT to help plan the attack. So I think you can see like two ends of the spectrum almost, of someone who's really using kind of multimodal capabilities and someone who's using the simple chat interface. But both are concerning. Yeah.
Terrifying. Well, I'm afraid there's lots more questions here, but I'm afraid we can't take them. But thank you, all three of you. Thank you again for managing the technical problems. fascinating area, terrifying, but thank you very much.
Thank you.